A very good morning, students. Today we are going to see the topic vacuum circuit breaker. So, first of all, we should know what is a circuit breaker, where it is used. So, the circuit breaker is a simple switch which is used in the power system for making and breaking the circuit. As we discussed in the previous class, there are n number of circuit breakers based upon the interruption medium, based upon the operating voltage, and based upon the operating environment. So, based upon the interruption, there are simple classifications such as oil circuit breaker, air circuit breaker, then this vacuum circuit breaker, then SF6 sulfur hexafluoride circuit breaker are available. So today the point of discussion is vacuum circuit breaker. So we are going to know what is a vacuum circuit breaker, how it operates, and what are all the advantages in this vacuum circuit breaker. So this is the topic outline. So we're going to see in detail about the components, working construction, key elements, advantages, disadvantages, and applications. So first of all, we should know what is a vacuum circuit breaker. So it is a device that stops the flow of electric current in the system in the event of over or under voltage or short circuit. So you have to note down the point that is over or under voltage or short circuit. So, what are the consequences of this over voltage or under voltage or in short circuit? So, basically, the power system needs to be operated in the prescribed manner, that is, not violating the level of voltages, either in the higher manner or the lower manner. If the voltage exceeds the prescribed level, that is, an threshold voltage, then the over voltage problem occurs, which means the enormous amount of voltage being transmitted than the prescribed level that leads to heating of conductors, breaking of insulating paths, and so the associated devices which are connected into the power system will also get disturbed. It serves as a safety measure to prevent the dangerous situation and protect the electrical equipment. A vacuum circuit breaker is a specific type of circuit breaker that interrupts the current in the vacuum. A small arc is often created in the circuit breaker when the contact moves apart. The arc must be extinguished in order to control the current or stop the current completely. These are all the components of circuit breaker. The components are very simple. One is a fixed contact and another one is a moving contact. As the name implies, the contacts will be in the fixed position and another one will be the movable position. The next one is the vacuum circuit interrupter, then actuator mechanism. The fixed contact, the electricity flows into the circuit and goes through the fixed and stationary contact. This contact stays in a place where the circuit is opened or closed. The circuit flows from the fixed contact to the movable contact. If the circuit is stripped, the movable contact moves away from the fixed contact, stopping the flow of electricity. When the moving and making the circuit and moving away from the contact and breaking the circuit, there the arc is being produced. That arc is simply quenched in the vacuum medium. In a vacuum circuit breaker, the arc is created in the vacuum. A vacuum is an excellent insulator and quickly extinguishes this arc. The next one is an actuator mechanism. This actuator mechanism is to create the movement and also a tripping mechanism. Whenever the circuit is tripped, it forces the actuator mechanism to move the circuits apart, that is, making the moving contact to move front and back based upon the necessity. If it want to make a contact, the moving contact will move towards the fixed contact. If it want to break the contact, it will move away from the fixed contact. Working principle of vacuum circuit breaker. Since the circuit breakers are typically protect against the overcurrent and short circuit, they are simple and powerful operating devices. They use thermal and magnetic trip to detect each. When the circuit trips, it creates a chain of event inside the insulating medium. In case a vacuum circuit breaker, the insulating medium is vacuum. Once the circuit trips, the actuator mechanism forces the movable contact to break the connection when it is with the fixed contact. The broken connection ionizes the metal vapors, creating the electric arc between the two contacts. This arc can damage equipment and must be excused or extinguished quickly, especially in high voltage situations. On the right side, we have shown the vacuum circuit breaker construction diagram. A vacuum circuit breaker features a similar construction to each other circuit breaker with an exception of insulating vessel, which is in the vacuum. The arc chamber is made up of steel and houses the main components including the movable and fixed contact in the vacuum interrupter. As the contacts are one of the most critical components of VCB, it is essential to use suitable materials. Contacts are usually made up of copper and chrome or copper bismuth as the materials transfer the electricity well. But during the high voltage interruption process, those metals tends to damage because of the high heat produced. So periodical maintenance has to be done and suitable replacement has to be made. So the first one is an insulating envelope. The next one electrodes, vapor condensation chamber, bellows shield, and you could see the bellows, fixed and moving contacts, and then the arc, then shield support flange, end shield, and fixed contact. So the making and breaking concepts has happening inside the vacuum environment. That is what the vacuum circuit breaker does. So this is the mechanical diagram of the vacuum circuit breaker. You could see the actuator mechanism is playing a crucial role which actuates the process of making and breaking circuit in a closed environment. For moving that moving contact, this actuator mechanism have a motor inside which will pulls back the moving contact if we want to open the circuit. And if you want to close the circuit, that actuator mechanism actually closes the moving contact towards the fixed contact. So these are all the properties of contact material. So as we said already, because of the high voltage operations, we should select the fixed and moving contact material in a clear manner. The material should have high electricity conductivity so as to pass the normal load currents without overheating. The contact material should have low resistance and high density. The material should possess high thermal conductivity so as to dissipate rapidly a large heat generated during the arcing. Then the material should have a high arc withstand ability and low current chopping level. The following are the advantages of this vacuum circuit breaker. It does not require an additional filling oil or gas. They do not periodic refilling. Then rapid recovery of high dielectric strength and the current interrupts that only a half cycle or less than arcing occurs after the proper contact separation. So the arc quenching process is very very fast in this vacuum circuit breaker than any other circuit breaker. The breaker unit is compact and self-contained. It can be installed in any required destination and also in any orientation. Either it can be fixed in the vertical or horizontal, and based upon the requirement, we can place it in any manner. So, because of above reasons, together with economic advantages offered, vacuum circuit breaker has a high level of acceptance overall in the market. Then it has some limitations too. The requirements of high technology for vacuum interruptions. It needs additional surge separators for interruption of low magnetizing current in certain range, loss of vacuum due to transit damage or failure in the entire interrupter, making it useless. It cannot be repaired on the site. It has to be moved to the proper place, and the operation for making it bringing back to the original state is a quite complex process. So because of the short gap and excellent recovery in the vacuum circuit breaker, they are useful for high speed making switches in many industrial applications. When the voltage is high and current to be interrupted is low, these circuit breakers have a definite superiority over other breakers. For low operating ranges, low fault interrupting capacities, the cost is low in comparison with other interrupting devices. Because of this least requirement of maintenance, these breakers are very suitable for the system which requires a range of 11 kV to 33 kV. So we came to the end of the session. We discussed about the circuit breakers, especially the vacuum circuit breaker, how it operates, and what are all the specialities about those vacuum circuit breakers. And also we discussed the constructional features of vacuum circuit breakers, and we discussed advantages, disadvantages, and real-time applications of the vacuum circuit breaker. Thank you for your patient listening. We'll be discussing another interesting topic in the upcoming video. Thank you all.